Hello everyone, welcome to another video of Digital Logic. Today in this video we are going to discuss about universal gate. In the previous three video we described about what is NAND gate, AND gate and OR gate. Now in today's video we will discuss about universal gate, what are the types of universal gate, advantages of using universal gate, and one of our important universal gate, that is NAND gate. So let's begin our video. First of all, what is universal gate? It is the logic gate which can implement any Boolean function without using other type of gate. Other type of gate here means that it does not use other basic gates to perform the Boolean functions. Any kind of the Boolean function like Boolean multiplication, Boolean addition and Boolean inversion can be performed using only the universal gate. There are two types of universal gates. They are NAND gate and NOR gate. The main advantage of using universal gate is that any kind of logical operation like Boolean multiplication, Boolean addition and Boolean inversion can be performed using universal gate only. And also it is easier and economical to fabricate NAND and NOR gate. So in practical life, in different kind of the ICs, we use NAND and NOR gate instead of our basic gates. Now we will begin our universal gate. We will study NAND gate, and in the later video we will describe about NOR gate. So first of all, what is NAND gate? It is the logic gate whose output is low when all the inputs are high. NAND gate inverts the result of AND gate, so it is named as NAND. That means the first letter of the NAND represents the NOT, and NAND gate means not AND. From the definitions of the NAND gate, you can see that it is the combination of NOT gate and AND gate. So we will combine our AND gate and NOT gate to make the NAND gate. This first part represents the AND gate. Here A and B represents the input of AND gate, and Y is equal to AB represents output of AND gate. As you can see from the definitions of the NAND gate, it inverts the result of AND gate, so output of AND gate must be inverted. To invert the result of output, we use another gate, that is inverter, or also called NOT gate. So second part of our NAND gate will be the NOT gate. Here you can see output of AND gate is connected to the input of NOT gate, which inverts the result of AND gate. Combination of this first part and second part can be equivalently represented in digital logic by the symbol, this one, and this is the symbol of our NAND gate. Here A and B represents the input of AND gate, and a small bubble represents NOT gate, and Y is our output for the NAND gate. Come to the truth table for two input NAND gate. Total number of possible combinations for the input is given by n is equal to 2 to the power small n, where this small n represents the number of input. In our case we have two input, so the number of possible combinations for the input is equal to 4. Table shows the combinations of the input. In table A, AB represents the input, Y is equal to AB represents output of our first part, that is output of our AND gate, and Y is equal to AB complement represents output of our second part, or we call it as a final output of our NAND gate. Now we will move toward the logic gate simulator, where we will combine AND gate and NOT gate, and also we will compare output of combinations of OR gate and AND gate to the actual NAND gate. So this is my logic gate simulator. First of all, I need an AND gate and two input. This will be my two input. Let this be input A and input B. And also I need my output and one NOT gate. I'll connect my input to the AND gate. This A and B are my inputs, and I will connect output of AND gate to the NOT gate, and also my NOT gate to the final output. This will be my final output Y. Also I need the NAND gate. I need two input. Let this input be A and this will be B, and this is my Y. You can see in both the cases when the inputs are low but output is high. Likewise, when A is high in both the cases, you can see output is still high. And when A is low in both cases and B is high, you can see output is high. And when both the inputs are high, you see that output is low. Hence, we have verified that the combinations of AND gate and NOT gate form of NAND gate. Onto the timing diagram of NAND gate. We know that timing diagram represents the graphical form of inputs and their possible output. To draw the timing diagram for NAND gate, let's my two input signals be input A and input B. Here the number 0 and 1 represent low and high. In the input A and input B, both the input A and B are changing their values from 0 to 1 or 1 to 0 in some points. We need all the points in input A and input B to draw the possible graphical representation for our output. I have drawn a red dotted line here to represent the point where input A, input B or both are changing their values. To draw the graphical representation for our output, we need a truth table for our NAND gate. This is my truth table for NAND gate. You can see from the table its output is low when both the inputs are high. So on the basis of this truth table, my possible outcome will be this one. As you can see in the truth table, when both the inputs are 0, output is 1. Likewise, when both the inputs are 1, its output is 0. And also when A is 0 and B is 1, output is 1. Similarly, you will be able to draw the output for rest of the part by using the truth table.